Hi everyone, welcome back to A Square Maths Academy. So today's topic is nothing but differential equations. This is also most important for intermediate maths to be as well as further studies also. అంటే మనకు డిగ్రీలో కానీ బీటెక్లో కానీ చాలా యూస్ఫుల్ ఉన్న టాపిక్ ఇది. మేజర్గా వచ్చేసి ఇక్కడ బేసిక్స్ ఉంటాయి. నెక్స్ట్ ఫర్దర్ స్టడీస్లో చాలా యూస్ఫుల్గా ఉన్న టాపిక్ ఇది. ఓకే, సో let us start the class. Now before going to starting the class, I request you all, please subscribe to our channel A Square Maths Academy. Okay, now let us start this class. Okay, see here differential equations are nothing but, see here, first of all, in this chapter intermediate lo 2 plus 4 plus 4 plus 7 అంటే one very short question, two short questions, one long question వస్తామా. కాకపోతే ఇప్పుడు మనకు ఈ పాండమిక్ సిచ్యువేషన్లో ఫర్దర్గా అంటే ఇంకా చాయిస్ అనేది ఇంక్రీజ్ చేయడం జరిగింది, ఇంక్రీజ్ చేస్తాను కూడా చెప్పడం జరిగింది. కాబట్టి మేజర్గా వెరిషార్డ్ క్వశ్చన్స్ కూడా ఇంక్రీజ్ అయ్యే అవకాశం ఉంది. మేజర్గా వెరిషార్డ్ క్వశ్చన్స్ కూడా మనకు చాయిస్ కింద ఇచ్చే అవకాశం ఉంది. కాబట్టి ఇంకొక వెరిషార్డ్ క్వశ్చన్ కానీ ఇంకో షార్ట్ క్వశ్చన్ కానీ ఇంక్రీజ్ అయ్యే అవకాశం ఉంది. ఎందుకంటే షార్ట్ క్వశ్చన్స్తో పాటు వెరిషార్డ్ క్వశ్చన్స్తో పాటు షార్ట్ క్వశ్చన్స్ లాంగ్ క్వశ్చన్స్ కూడా ఇంక్రీజ్ చేస్తున్నారు. కాబట్టి ఈ మార్క్సే కన్సిడర్ కాకుండా ఇంకొన్ని ఎక్కువ వచ్చే అవకాశం కూడా ఉన్నది. ఓకే, సో కాబట్టి మేజర్గా అయితే చాలా సింపుల్ ప్రాబ్లమ్స్ ఉంటాయి వెరిషార్డ్ క్వశ్చన్స్కి వచ్చేసరికి. సో దీన్ని మాత్రం ఈజీగా ఎట్లా నేర్చుకోవాలి అనే దాని మీద కాన్సన్ట్రేషన్ చేద్దాం. సో సి ఫస్ట్ ఆఫ్ ఆల్ డిఫరెన్షియల్ ఈక్వేషన్. సో డిఫరెన్షియల్ ఈక్వేషన్ ఈజ్ నథింగ్ బట్ an equation involving one dependent variable and its derivatives with respect to one or more independent variables is called a differential equation or DE. Differential equation or DE. Clear? So an equation involving one dependent variable అంటే కామన్ గా డిఫరెన్షియల్ అనగానే కంప్లీట్ గా డెరివేటివ్ మీద ఉన్న డెరివేటివ్ మీద డిపెండ్ అయిన ఈక్వేషన్స్ ఉంటాయని అర్థమైపోవాలి. ఎందుకంటే డిఫరెన్షియల్ ఈక్వేషన్స్ కామన్ మనకు ఫస్ట్ ఇయర్ లో డిఫరెన్షియేషన్ నేను నేర్చుకుని ఉంటారు. అంటే డిఫరెన్షియేషన్ అంటే dy by dx కానీ అంటే dy by dx ఆఫ్ sin x, dy by dx ఆఫ్ cos x లైక్ దిస్. ఇక్కడ ఈక్వేషన్ ఏమి ఉండదు కాబట్టి దీని యొక్క డెరివేటివ్ మాత్రమే ఉంటుంది. అంటే వేరియబుల్ యొక్క డెరివేటివ్స్ ఉంటాయి. ఈ వేరియబుల్ యొక్క డెరివేటివ్స్ తోని ఈక్వేషన్ ఫామ్ అయి ఉంటుంది. అంటే ఈక్వేషన్ అంటే కామన్ మనకు ax square plus bx plus c equals 0 we take care. This is nothing but polynomial equation or quadratic equation like that here. అంటే ఈక్వల్స్ 0 ఉండి ఆటోమేటిక్గా స్క్వేర్ ఎక్స్ టర్మ్స్ ఉన్నా కానీ లేకపోతే కాన్స్టెంట్ ఉన్నా కానీ దాన్ని ఈక్వేషన్గా మనం పరిగణిస్తాం. కాబట్టి ఇప్పుడు డెరివేటివ్స్లో ఈక్వేషన్స్ ఎలా ఉంటాయంటే dy by dx అనేది కామన్గా మనకు డెరివేటివ్ కదా. dy by dx హోల్ స్క్వేర్ ప్లస్ 2 dy by dx ప్లస్ x ఈక్వల్ 0 లైక్ దట్ ఇయర్ ఇలా ఉంటుంది అన్నమాట. అంటే డిఫరెన్షియేషన్లో ఈక్వేషన్స్ ఉంటే వాటిని డిఫరెన్షియల్ ఈక్వేషన్స్ అంటాం. అంటే టర్మ్స్ అనేటివి డిఫరెన్షియలేషన్ అంటే డెరివేటివ్స్ మాత్రమే ఉంటాయి టర్మ్స్లో. ఆ టర్మ్స్ లోపల మేజర్గా an equation involving one dependent variable and its derivatives. అంటే మన కామన్ dy by dx అంటే సో d by dx ఆఫ్ y. ఓకే, సో దిస్ ఈజ్ ఇండిపెండెంట్ వేరియబుల్. దీని మీద డిపెండ్ అయింది y కాబట్టి ఇది డిపెండెంట్ వేరియబుల్. దేని మీద డిపెండ్ అయింది? x మీద డిపెండ్ అవుతుంది. ఇట్స్ డెరివేటివ్స్ విత్ రెస్పెక్ట్ టు వన్ ఆర్ మోర్ దెన్ వన్. ఒకటే ఇండిపెండెంట్ వేరియబుల్ ఉంది. డిపెండెంట్ వేరియబుల్ ఒకటే ఉంది. dy by dx is nothing but differential equation. సో ఫస్ట్ డెఫినేషన్ ఇస్ ఓవర్. ఓకే, నెక్స్ట్ వచ్చేసి ఆర్డినరీ డిఫరెన్షియల్ ఈక్వేషన్ ODE. మేజర్గా వచ్చేసి సెకండ్ ఇయర్లో మనకి ఇక్కడ 2Bలో ODE మీద మనకి మేజర్గా ఉన్న ప్రాబ్లమ్స్ ఉన్నాయి. PDE అంటే పార్షియల్ డిఫరెన్షియల్ ఈక్వేషన్ మీద నెక్స్ట్ వచ్చే డిగ్రీలో కానీ లేదంటే బీటెక్లో కానీ నేర్చుకునే అవకాశం ఉంటుంది PDE మీద. ఇక్కడ మేజర్గా ఓన్లీ ఇక్కడ వరకే, ఓన్లీ ODE వరకే ఉంటాయి. దీనిలో జస్ట్ ఇంట్రడక్షన్ అంటే PDE అంటే ఏంటిది అనేది నేర్చుకున్నాం. దాని తర్వాత మిగతా దాని గురించి ప్రాబ్లమ్స్ ఏమి ఉంటాయి, దీని మీద ఎక్కువ అసలు కాన్సన్ట్రేషన్ ఏమి ఉండదు. ఓన్లీ ODE మనకి అంటే ఆర్డినరీ డిఫరెన్షియల్ ఈక్వేషన్స్ మీదనే మనకు కాన్సన్ట్రేషన్ చేయడం జరుగుతుంది. అంటే ఇక్కడ ఉండే కూడా అదే సెకండ్ ఇయర్ సిలబస్. ఓకే, సో see here. An equation involving one dependent variable and its derivative with respect to one or more independent variables. So with respect to one independent variable, then that derivative is nothing but dy by dx plus 5x plus c are equals 0. So this is differential equation having only one independent variable. So that's why that equation is called ordinary differential equation. Ordinary differential equation is nothing but contains only one independent variable. Only one independent variable, then that is called ordinary differential equation. Okay, next partial differential equation, that is nothing but more than one independent variables is called partial derivative equation. Partial derivative, that is nothing but like dou z by dou x plus dou z by dou y is equals 0. So this is partially derivative. So partial derivative equations, partially differential equations, partial differential equations. So that means here two independent variables are existing. This one and this one, x and y are independent variables. Z is dependent variable. Z is depending on x. Here Z is depending on y. Clear? So dou z by dou x plus dou z by dou y equals 0. So this type of differential equation is called partial differential equation. So ordinary differential equation, partial differential equation is completed. Next, order. So we know the order of a differential equation. Okay, so these are differential equations examples. ఇవన్నీ కూడా differential equations అవుతాయి. ఈ differential equations లో we find out the order. So order of a differential equation is the order of highest derivative. So what is the highest derivative? First of all, we verify it is. Okay, in this case we have only dy by dx. So this is only one derivative, highest also that is 1. So that is nothing but order of this equation is nothing but 1. dy by dx, first derivative, only one derivative is there. So here d square y by dx square is there, dy by dx whole cube is there, d square y by dx square whole square is there. Clear? So we find out here order. So what is order? Highest derivative is nothing but order. So what is the highest derivative here? So this is dy by dx. This is d square y by dx square. So this is the order. Highest derivative is nothing but 2 times derivated here. Clear? So that's why this is highest order, highest derivative of this equation. So that's why this will be taken as order. So order of this equation is nothing but 2. Okay. So what about this one? See here, d square y by dx square is there. Here dy by dx whole square is there. So here also directly we take here, this is the highest order. Okay now. So highest derivative is nothing but taken as order. So this is also order 2. So here also same we take here. So what is the order of this equation? Again we take here highest derivative. So here dy by dx is there. Here d square y by dx square is there. So this is the highest derivative. So that's why this is taken as order. So here observe this one. Order of this equation 1, order of this equation 2, order of this equation also 2, Here also 2. Highest derivative is nothing but taken as order. So here all are having 2, 2, 2, 2. So this is the definition of order also. So what is definition? Order of a differential equation is the order of highest derivative. Clear? So this is nothing but highest derivative we taken as order. Clear? Next one is nothing but degree. Okay. So what is degree? Degree is nothing but largest exponent of highest order derivative. So what is that? Nothing but yes here. అంటే highest derivative యొక్క exponent ఏది ఉంటుందో దాన్ని డిగ్రీగా తీసుకుంటాం. సో highest exponent of largest, so highest derivative, so largest exponent of highest derivative. So what is the derivative of this one? Highest derivative this one. Here dy by dx, here d square y by dx square is there. Clear? So d square y by dx square, here also d square y by dx square, here also d square y by dx square. Clear? So exponent of highest derivative. Exponent of highest derivative we taken as degree. Okay. So order is nothing but highest derivative. Highest derivative is nothing but order. Highest derivative exponent is nothing but degree. Okay now. So see here. Now this is okay. Here this is highest derivative. So that's why exponent of this derivative we taken as degree. So what is the degree? This is degree. Degree of this equation is 2 also. Okay now. So what about this one? So this is whole power of 1 we taken as. So that's why this will be taken as degree. So degree of this equation is nothing but 1. So order 1 as well as degree also 1. Order 2, degree also 2. So what about this one here? So what is the difference here? So these are all integers, positive integers, but here not taken integer. Clear? So see here, observe this one. Ikkada integer unte it is direct rather me. D square y by dx square only whole power 1 we taken. But here not given integer. Integer ivale. Ikkada not given integer. Okay na? So we can changing as a differential equation as a polynomial equation like this one, x square plus 2x plus 1 equals 0. Not on this one, x cube like 4x square like that. Okay, so like this equations I will take here. First of all, this is not integer. Integer కాదు కాబట్టి ఇంటీజర్ లోకి చేంజ్ చేసిన తర్వాత అప్పుడు దాని యొక్క డిగ్రీని ఫామ్ చేయాలి. ఇంటీజర్ చేంజ్ చేసిన తర్వాత డిగ్రీ ఆర్డర్ కు మనకు ఇంటీజర్ తో సంబంధం లేదు, ఎందుకంటే హైయెస్ట్ డెరివేటివ్ ఇస్ నథింగ్ బట్ టేకెన్ యాజ్ ఆర్డర్. హైయెస్ట్ డెరివేటివ్ ఆర్డర్ కాబట్టి మనకి ఇబ్బంది లేదు. కానీ డిగ్రీకి వచ్చేసరికి అక్కడ ఎక్స్పోనెంట్ అవసరం ఉంది కాబట్టి ఎక్స్పోనెంట్ అనేది పాజిటివ్ ఇంటీజరే కావాలి. ఓకేనా? సో పాజిటివ్ ఇంటీజర్గా చేంజ్ చేయాలి. ఎలా చేంజ్ చేయాలంటే see here, whole power of 3 is there, whole power of 5 by 3 is there. So how to get here whole power of 5 by 3 in terms of integer? When you are multiplied by 3, that means here cubing on both sides we get here integer. Clear? So what we get here? D square y by dx square whole power of 3 that equals to 1 plus dy by dx whole square whole power of 5 by 3 whole power 5 by 3 whole cube we get here. Okay na? Cube and by 3 cancel, we get here only 5. Okay na? 5 we get here. Okay. So now see here, observe this one, d square y by dx square whole power of 3 is there, that equals to 1 plus dy by dx whole square whole power of 5 is there. So what is degree? This one be degree or this one is degree? Here 3 is there, here 5 is there. So exponent is nothing but positive exponent is nothing but positive integer exponent is nothing but taken as degree. But here what is degree definition here? The highest, the largest exponent of highest order. Clear? So what is the order of this equation? That equation is nothing but 2. Because dy by dx is there, whole power of 2. This is not order. This will be taken as order. So order exponent is nothing but degree. So what is the degree of this equation? 3 is the degree. Next, what about this one? See here, order is 2, okay. So here whole power of 1 by 4 is there, that is also not integer. So we can change into integer. How to change here? By quadratic equations, clear? By, so whole power of 4 is there, clear? So now dy by dx, whole power of dy by dx is there, dy by dx whole power of 1 by 2 plus d square y by dx square whole power of 1 by 3 whole power of 1 by 4 is there, clear, right? So squaring and squaring, by squaring, now what we get here, whole power of 4 we get here, 0 power of 4, that is also 0. So 4 gets cancelled, we get here dy by dx whole power of 1 by 2 plus d square y by dx square whole power of 1 by 3 we get here, that equals 0. Okay, so that equals 0, then what we get here, equals to minus of this one, we are taking that side. Okay, so whole power of 1 by 2 is there, whole power of 1 by 3 is there, whole power of 1 by 3 whole power of 1 by 2. But here these are not integers, we can change into integers. How to change here? Now squaring on both sides. First of all, what we get here, squaring on both sides, what we get here, whole power of 2 whole power of 2 we get here, 2 gets cancelled, here we get here only 1. Okay, now but here again 2 by 3 we got here, so that is not integer. So when we get here integer, again cubing on both sides. So what we get here, whole power of 3, whole power of 3 is nothing but into 3, 3 gets cancelled, now we get it 2. Okay, now so we get like this here, dy by dx whole cube, that equals to squaring on this one is, that is nothing but we get here plus, minus can change it to plus, so d square y by dx square whole power of 2 we get here. Now I will write here, what is the order here? Order is nothing but this one, already we written here 2. So the exponent of derivative, highest derivative, exponent of highest derivative taken as degree. So highest derivative is nothing but d square y by dx square. So that degree is nothing but 2. So this is the degree, not 3. Okay, degree of this equation is nothing but 2. Okay, so these are the differential. Next topic is nothing but solution and general solution. Solution and general solution time ledu. Solution is nothing but solution of a differential equation is a relation between independent variable and dependent variable, dependent and independent and arbitrary constants. ఇక్కడ మేజర్గా వచ్చేసి డిపెండెంట్ వేరియబుల్ అండ్ ఇండిపెండెంట్ వేరియబుల్ నుంచి మనకి ఇంతకుముందు ఆల్రెడీ డిఫరెన్షియల్ ఈక్వేషన్ మీద కాన్సన్ట్రేషన్ చేసినప్పుడు ఆటోమేటిక్గా మనం తెలుసుకున్నాం ఏది డిపెండెంట్ వేరియబుల్ అవుతుంది, ఏది ఇండిపెండెంట్ వేరియబుల్ అవుతుంది. ఇండిపెండెంట్ వేరియబుల్ ఇస్ నథింగ్ బట్ ఇన్ డినామినేటర్, అంటే dy by dx లో dy by dx plus 5x plus equals to c is there, suppose we take here. Okay na, dy by dx plus 5x plus c. So dy by dx, this is nothing but independent variable, this is nothing but dependent variable by independent variable, and 5x and c are the arbitrary constants. So arbitrary constants already c is there, so c కాబట్టి సింగిల్ డెరివేటివ్. ఓకే, a కామా b కానీ అలాగే a కామా b కామా c కానీ ఉంటాయి కాబట్టి అప్పుడు 2 డెరివేటివ్ సెకండ్ డెరివేటివ్ కూడా యూజ్ చేయడం జరుగుతుంది. ఎలా అంటే ఇలా, జనరల్ ఈక్వేషన్, ఏ సొల్యూషన్ ఆఫ్ ఎ డిఫరెన్షియల్ ఈక్వేషన్, in which the number of arbitrary constants is equal to the order of differential equation. So what is the order of differential equation? That is 1. So how many arbitrary constants are exist here? Only 1. Suppose one arbitrary constant is there, we have to derive only one time. Okay, 2 arbitrary constants are there, then we have to derive 2 times. అంటే 2 ఉంటే 2 టైమ్స్ చేయాల్సి వస్తుంది, 3 ఉంటే 3 టైమ్స్ కూడా చేయాల్సి ఉంటుంది డెరివేటివ్స్ని. ఓకేనా, ఎప్పుడు ఆర్బిటరీ కాన్స్టెంట్స్ అనేది 3 ఉంటే ఆ ఆర్బిటరీ కాన్స్టెంట్స్ని రిమూవ్ చేయడానికి 3 ఉంటే 3 టైమ్స్ డెరివేటివ్ చేయాల్సి వస్తుంది, 2 ఉంటే 2 టైమ్స్ డెరివేటివ్ చేయాల్సి వస్తుంది, 1 ఉంటే 1 టైం డెరివేటివ్ చేయాల్సి వస్తుంది. ఓకేనా, సో ఆర్బిటరీ కాన్స్టెంట్స్ ఈజ్ ఈక్వల్ టు ది order of the differential equation. Okay na, so that's why this is the general solution. Okay, now exercise 8a లో మనకు సేమ్ దీని మీద డిపెండ్ అయిన ప్రాబ్లమ్స్ ఉన్నాయి. Now we will start the exercise 8A. Okay, exercise 8A. First bit, first problem. Find the order of the differential equation obtained by eliminating the arbitrary constants b and c. From the equation xy equals to c e power of x plus b e power of minus x plus x square అమ్మా. కామన్ అయితే మనకి ఈ ఈక్వేషన్ లో 2 ఆర్బిటరీ కాన్స్టెంట్స్ ఉన్నాయమ్మా. కాబట్టి మనం 2 టైమ్స్ డెరివేట్ చేయాలి. ఆటోమేటిక్గా దాని యొక్క ఆర్డర్ ఏమవుతుందంటే నెంబర్ ఆఫ్ ఆర్బిటరీ కాన్స్టెంట్స్ ఈజ్ ఈక్వల్స్ టు ది ఆర్డర్ ఆఫ్ డిఫరెన్షియల్ ఈక్వేషన్. That is the general solution. Already definition also there. What is the general solution? General solution is nothing but solution of a differential equation. The number of arbitrary constants is equals to the order of the differential equation. So here find out the order of this equation. So how many arbitrary constants are there? The solution I will write here. Number of arbitrary constants is equals to 2. So similarly already 2 are the arbitrary constants. Then what is the order of this equation? The order of differential equation is equals to number of arbitrary constants. Number of arbitrary constants, that equals to 2. So what is the order? Order is nothing but 2. Okay, now order is nothing but 2. So next, find the order of differential equation of the family of all circles with their centers at the origin. So what is the equation having this circle? Equation of the circle. The equation of the circle having origin as a center. As a center is nothing but x square plus y square is equals to r square. X square plus y square equals to r square. This is the equation of the circle having the center 0, 0. So 0, 0 is nothing but origin. So how many arbitrary constants are exist here? So these are not arbitrary constants here, x and y. Clear? So this is only arbitrary constant. So how many there are? Only one is there. So number of arbitrary constants is equals to 1. So what is the order? Order also same, that equals to arbitrary constants. That means here order of differential equation is nothing but 1. So these are the solutions. Okay, right now second one, see here. Form the differential equation of the following family of curves where parameters are given in the brackets. Clear? So how many parameters are there? Only one. So that will be taken as arbitrary constants. Clear? So how many arbitrary constants are exist? Only one arbitrary constants are there. So given equation derivative only one time. Okay now. So how to change here? Now differentiative with respect to x. Then what we get here? Then dy by dx that equals to c is constant. So x minus c whole square is there. So derivative of x square we write now 2 into x minus c. Now again derivative of x minus c, that value is nothing but 1 we get here. That is nothing but we get only c into 2 of x minus c we get here. Okay now. So dy by dx can written also I will take here y1. So y1 is nothing but 1 time derivative. y2 is nothing but 2 time derivative. Clear? So now c equals to, say y1 equals to c into this one. Okay, 2c of x minus c we get here. Okay. So y equals this one and y1 equals to 2c of x minus c. Okay now. So see, observe this one here. Then after we are taking this equation number 1 and this is equation number 2. Okay now. So how to remove here? See here when arbitrary constants are removing here, eliminating arbitrary constant, అవి ఎన్నున్నో అన్నిసార్లు డెరివేట్ చేస్తే అప్పుడు అవి వెళ్ళిపోవాలి, అంటే రిమూవ్ కావాలి, ఎలిమినేట్ చేయబడాలి. క్లియర్? సో హియర్ ఓన్లీ వన్ ఆర్బిటరీ కాన్స్టెంట్ ఈస్ దేర్, సో దట్ ఈస్ నాట్ removed here. Clear? So y1 equals to 2c into x minus c we got here. This is not removed, arbitrary constant is not removed. So what we do? So once again we are not derivating, only why? Because we have only one arbitrary constant, so that's why we have to derivate only one time. So there are no derivative times. Clear? So that's why what we do, see here, we are taking 1 by 2 or 2 by 1, take any one, okay, and dividing 1 by 2. So what we get here, see here, y by y1. So y by y1 or y1 by 1 by 2. 1 by 2 means this is y by y1, that equals to c of x minus c whole square by 2c of x minus c we get it. 2c of x minus c. Okay na? So now c removed here. X minus c, 1 x minus c cancel. Okay na? So now what we get here? Y by y1 is equals to x minus c divided by 2 only. X minus c divided by 2 only. Okay na? So now cross multiply. What we get here? 2y by y1 is equals to x minus c we get here. Okay na? So now c equals to what right now? C take this side and this one take that side. We get here c value. C equals to x minus 2y by y1. 2y by y1 we get here. Now you substitute here c value either in equation 2 or in equation 1. Then we get the differential equation. Okay. So c will be removed in terms of y and y1. Okay now. So see here, on substituting c in equation 2, what we get here equation 2? So y1 is equals to 2c. c is nothing but this one, okay? X minus 2y by y1 into x minus c. X minus c, okay na? So x minus c is nothing but like this here, direct class we substitute here, 2y by y1. Okay, so 2 into c is nothing but x minus 2y by y1, x minus 2y by y1, and x minus c is there, x minus c equals already we got here 2y by y1, directly we substitute here. Okay, so y1 is equals to 2 into 2 4xy. So here first of all 2 into y1x or xy1 minus 2y by y1 into 2y by y1. 2y by y1. Okay na? So now y1 into y1 square into y1 cube we get here. So y1 cube is nothing but dy by dx whole cube, that is, okay, that equals to 2xy1 into 2y, that is nothing but 2 into 2 4yx, that is 4xy y1. So minus 2 into 2 4 into 2 8 y into y square. Okay na? So that this is the equation. Y cube is equals to 4xy y1 minus 8y square is nothing but differential equation. So how to take differential equation? Y1 is nothing but not only y1 is nothing but dy by dx. So dy by dx whole cube, that equals to 4xy into dy by dx minus 8y square we get here. So that is the differential equation. Okay. Okay, now second one here, xy equals to a e power of x plus b e power of minus x is there. So here two arbitrary constants are there. So that's why we have to derivate 2 times with respect to x. Okay, so derivative with respect to x. What we get here? So UV method, UV rule. So two variables are there, x and y. So that's why 2 times UV method we are applying. Okay. So UV method is nothing but U into V d by d. So U into dv by dx plus V into du by dx. Okay na? Ante x into dy by dx plus y into dx by dx is nothing but 1. Okay, that equals to here a into e power of x derivative also x minus b e power of minus x we get here. E power of minus x derivative minus e power of x. So b comma here constant as this we get here. So again we are derivating both sides here. Derivative with respect to x. So what we get? Why? Because two arbitrary constants are there. We are derivating two times here. Clear? So that's why. Again we are applying UV method. So this is UV. So u into dv by dx plus v into du by dx. Clear? So that is nothing but x into dv by dx. That is nothing but again derivative of this one. What we get here? D square y by dx square we get here. Okay, na? Plus dy by dx as it is into this one. So that is nothing but 1. So plus dy by dx that equals to again derivative this one a e power of x as it is, e power of x derivative e power of x minus, so e power of minus x derivative minus e power of x, already minus is there, so minus into minus plus b e power of minus x we get here. So this value is nothing but equals to xy. Okay, given equation. So we are applying that one. So x into d square y by dx square plus 2 dy by dx is equals to, this value is nothing but xy. So that implies, I will write here, x d square y by dx square plus 2 dy by dx minus xy equals 0 is the required equation, required differential equation. Okay, so this is second problem. So third one, see here, y equals to a plus bx into e power of kx is there. So again arbitrary constants are given in brackets, so they are 2. So 2 times derivative. Okay na? So how to derive here? Derivative with respect to x. So what we get here? dy by dx we taken as y1. That is also derivative. Okay. So here uv method. This is u, this is v. Why? Because x having here also x. X ఉంది కాబట్టి వాటిని రెండింటిని uv method తీసుకుంటాం. u method u into dv by dx plus v into du by dx. Clear? So that is nothing but u as it is a plus bx dv by dx, that is nothing but derivative with respect to x, d by dx of e power of kx. E power of ax is nothing but a into e power of x. So k into e power of kx we get here. Okay, next plus v into e power of kx into du by dx. Du by dx is nothing but, this is constant, that value 0. Bx derivative is nothing but b. So we get here b. Okay, now so observe this one, a plus bx into e power of kx as it is we got here, that equals to y. So k into y also we write here. So y1 as it is. So up to this one into this one is nothing but y. Here k is there, we got it, k y plus b into e power of kx we get here, b into e power of kx. So now take this side here, y1 minus ky is equals to b e power of kx we get here. Okay, again we are derivating now. Again derivative with respect to x. Okay na? So what we get here? y1 is nothing but y2. దీని ఒక డెరివేటివ్ మళ్ళీ చేస్తున్నాం కాబట్టి y1 y2 కి వచ్చింది minus k as it is. This is nothing but y1 is equals to, so b as it is, e power of kx derivative is nothing but k into e power of kx. K into e power of kx we get here. Okay na? So see here, y2 minus k y1 is equals to b k e power of x we get here. So b into e power of kx, b into e power of kx is there. So that value, by using this condition, that is nothing but by using this one, b into e power of kx equals what we know, y1 minus ky. So we substitute here now, y2 as it is minus k y1 also as it is, that equals to b into e power of kx equals to, we write here, k of k as it is. First of all, I take k this one, and y1 minus ky, y minus ky. Okay now. So what we get here? y2 minus ky1 is equals to ky1 k into k square y, k square y get it. Okay now take this side. What we get here? y2 minus ky1 minus ky1 plus k square y is equals to 0. So y2 minus 2ky1 plus k square y is equals to 0. So this is the differential equation. So y2 is nothing but d square y by dx square, derivative with respect to x 2 times here, minus 2k into dy by dx only 1 time. So plus k square y is equals 0 with the required equation. Okay, ఇక్కడ ఆర్బిటరీ కాన్స్టెంట్స్ 2 ఉన్నాయి కాబట్టి 2 టైమ్స్ ఇస్తున్నాం, 1 ఉంటే 1 టైం చేస్తాం. ఓకేనా. నెక్స్ట్ y ఈక్వల్స్ టు a cos of nx ప్లస్ b, a కామా b ఆర్ ఆర్బిటరీ కాన్స్టెంట్స్, రెండు ఉన్నాయి కాబట్టి 2 టైమ్స్ చేయాల్సింది మళ్ళీ. క్లియర్. సో డెరివేటివ్ విత్ రెస్పెక్ట్ టు x. సో వాట్ వి గెట్ హియర్? y1 ఫస్ట్ డెరివేటివ్ is equals to a as it is cos of nx plus b, derivative is nothing but minus sin of nx plus b we get here. So I will write here in front of a minus. So minus a sin of nx plus b. Okay na. So x coefficient is what here? N is there. So into n also we write here. Okay na. Sin of x plus b of cos of nx plus b of derivative minus sin of nx plus b into n. Okay na. So again derivative both sides. Why? Because here a comma b are the arbitrary constants. 2 arbitrary constants are there. So 2 times derivative. Again derivative with respect to x. So what we get here? y1 can change into y2. 2 times derivative minus a sin nx plus b, derivative is nothing but cos of nx plus b into n. Already n is there, into n. So n into n, what we get here? N square we get here. Okay na. N, and this derivative nx is there. So again we get here n. One more n. So n into n, n square we get here. Okay na. So now y2 as it is, that equals to minus a into cos of nx plus b taken as y into n square. Okay na. So y2 plus n square y is equals to 0. So y2 is nothing but d square y by dx square plus n square of y is equal to 0 be the required equation of the differential equation. Okay na? Right. Next one is nothing but the rectangular hyperbola which have the coordinate axis as asymptotus. Clear? Asymptotus is nothing but here hyperbola having asymptotus. Clear? So that will be taken as, so the rectangular hyperbola, equation of the rectangular hyperbola which have the coordinate axis as asymptotus is xy equals to c square, where c is a parameter or c is arbitrary constant. Okay na. So xy equals to c square is the arbitrary constant. So this is the equation of the rectangular hyperbola. Okay na. So hyperbola మనం దీని గురించి నేర్చుకుంటాం కాబట్టి ఇక్కడ ఎంతవరకు అవసరం అంతవరకు తీసుకుంటాం. xy equals to c square is the asymptotus of a rectangular hyperbola. Clear? So see here xy equals to c square. Now only we have only one arbitrary constant c. So that's why we have to derivative only one time. So what we get here? This is u, this is v. U we have applied. So x into y1 first derivative plus y into x1. x1 is nothing but dx by dx, that is nothing but 1. That equals to constant derivative is nothing but 0. Okay, so what we get here? xy1 plus y is equals to 0 is the required equation. That implies x into dy by dx plus y is equals to 0 is the differential equation. Okay, అంటే మనకు డిఫరెన్షియల్ ఈక్వేషన్స్ లోపల ఆర్బిటరీ కాన్స్టెంట్స్ ఎన్ని ఉంటాయో అన్నిసార్లు మాత్రం డెరివేటివ్ చేస్తాం. ఓకే, రైట్. నెక్స్ట్ వన్, the ellipses with centers at the origin and having coordinate axis as axis. So we know that here solution, we know that the equation of ellipse, general equation, I will write it x square by a square plus y square by b square is equals to 1. X square by a square plus y square by b square equals to 1. Okay, so here two arbitrary constants are there, two times the derivative will be done. Okay, ఎలా చేస్తాం చూడండి. So 2x by a square derivative with respect to x, derivative with respect to x. So what we get, 2x by a square plus 2y by b square, that is nothing but 2y y1 by b square is equals to constant derivative is nothing but 0. ఓకేనా, డెరివేటివ్ చేస్తున్నాం కాబట్టి మళ్ళీ ఒకసారి ఇవ్వాలి కాబట్టి, so we are taking common 2 and take that side. What we get here, x by a square plus y y1 by b square is equals to 0 అవుతుంది. ఓకేనా, ఇప్పుడు మనం దీన్ని డెరివేటివ్ చేస్తాం, మళ్ళీ డెరివేటివ్ చేస్తాం కాబట్టి డెరివేటివ్ విత్ రెస్పెక్ట్ టు x. ఓకేనా, సో వాట్ వి గెట్ హియర్, x ఉంది కాబట్టి 1 అవుతుంది, 1 by a square ప్లస్ ఇక్కడ u విలువ అప్లై చేస్తే y ఇంటూ y2 అవుతుంది ప్లస్ y ఇంటూ y2 ప్లస్ y1 into y1 అవుతుంది మళ్ళీ కదా, బై b square is equal 0. డెరివేటివ్ u విల్ u into dv by dx ప్లస్ v into du by dx, u into dv by dx అంటే y into d by dx of y1, d by dx of y1 అంటే y2 అవుతుంది ప్లస్ y1 as it is d by dx of y, that is nothing but y1. ఓకేనా, సో నెక్స్ట్ వాట్ వి గెట్ హియర్, 1 by x a square plus y y2 plus y1 square. Okay, so 1 by a square plus y y2 plus y1 square by b square is equals to 0. Okay na, so what we get here, ఇక్కడ మనకి 1 by a square ఉంది, x by a square ఉంది. ఇది ఈక్వేషన్ 1 అంటే ఫస్ట్ డెరివేటివ్, ఇది ఈక్వేషన్ నెంబర్ 2 అనుకోండి. So on multiplying both sides by x, so what we get here, x by a square వస్తుంది, x by a square plus x into y into y2 plus x y1 square by b square is equals to 0 number. 0 into x square is equal to 0. So now we got here, this is equation number 2. So equation number 3. Okay, so on solving equation number 1 and 3, what we get here, on subtracting 1 and 3 we get here x minus a square minus this one, x minus a square cancel, this one minus this one we get here, this one ante y y1 b square minus x y2 plus x y1 square by b square is equals to 0. Okay na, now take LCM b square, so b square take the side, that value is equals to 0. So y y1 minus into this one minus xy y2 minus into this one minus x y1 square is equal to 0. Okay na, so take that side, x y2 plus x y1 square minus y y1 is equal to 0. So this is the differential equation. So how to write here, xy dy by dx, so d square y by dx square plus x into dy by dx whole square minus y into dy by dx is equal to 0. y1 ante dy by dx, y2 ante d square y by dx square. So this is the required equation. Okay, Nama, right?